Cool, I guess we can get started, yeah. All right, everybody, thanks for coming to deep dive into Virtual Kubelet. I'm Jeremy, I work at Microsoft.
Hi, I'm Lei Zhang. You can call me Harry, and I work for Alibaba Cloud.
So why are we here today? We're going to talk about what Virtual Kubelet is and how you could use it, how you could build a provider. But before we do that, let's define what a kubelet is. So a kubelet is an agent that runs on every node in your cluster, and it's responsible for watching the Kubernetes API and figuring out what pods need to run and making sure that that state happens. And the way it works is kind of like this. So you've got a kubelet running on some node, and it says, hey, API server, I'm a node. And then you, as a user, create some sort of pod spec through a deployment or some other mechanism. And the scheduler will say, what nodes do I have available? Where can I assign this thing? And it's going to assign it to a node. So the pod spec will be updated, and the pod spec will say, I am going to go to node X, or whatevs. And then meanwhile, the kubelet is doing a watch, specifically for spec.nodename equals node name. And when it sees that, it's going to go ahead and reconcile the state to figure out, is this a new pod? Do I want to create it? Is an existing pod? Do I need to do some sort of update, like change the image? And once it does that, it'll use the container runtime interface to say, create the container, update the container, delete the container, whatever it needs to do. So what is a virtual kubelet? A virtual kubelet is you can think of it as a controller that acts as a virtual node. There is no physical node backing it, but it appears as a node to Kubernetes. It'll have all the things associated with that, like resources that are available, memory, CPU, and you can use it to schedule pods. So when should you use it? If you're going to be using something that looks traditionally like a node, it's probably not the best case, because it doesn't have all of the capabilities that a regular kubelet would. But if you're going to do anything else, it can be an attractive use case. So something like bursting to a cloud or container as a service provider, like Azure Container Instances or AWS Fargate. Bridging to other orchestrators, like maybe you want to schedule some containers on Nomad. There's a provider to do that. If you want to schedule to Internet of Things control planes, that's another use case we've seen. And then at a workshop last year, somebody built a provider that ordered pizza with the Domino's API when pods were created. It was pretty funny. So how does it work? Obviously, it's magic. But it's not actually magic. It's really the same thing that we just saw. So Virtual Kubelet starts up, it has a daemon process, and it says, hey, Kubernetes API, I'm a node. And Kubernetes doesn't know that it's not a node. It just knows that somebody said, hey, I'm a node. And then you create a pod spec. The scheduler says, this pod should go on this node, which is going to be Virtual Kubelet. So then Virtual Kubelet's doing the same thing that the kubelet is. It's watching the API for any pods that are scheduled to it, just like any node would. And then it reconciles state, just like a kubelet would. But then instead of talking to the container runtime, it's really talking to something called a provider. And the provider is responsible for doing that bridge between what the pod is and where it needs to end up, some external service. This is what the anatomy of VK really looks like. There are really three parts. One of them is the daemon part at the top. Then there's the framework, and the framework has all of the stuff that's really reusable. It's going to have the reconciliation of state. It's going to have a definition of an API that providers have to implement. And then providers implement the actual calls back to those cloud providers or whatever they're going to schedule to. The framework works from a shared informer. It does state reconciliation. The kubelet has a couple of HTTP endpoints. If you're going to like exec into a container or try to get logs, those go through an HTTP endpoint, like if you do a kubectl exec. So the virtual kubelet exposes that and figures out how to invoke the provider, and the provider is responsible for translating that back down. It does things like tracing and logging so you can get good information about what's happening. So what's a provider? The provider is that mapping from the actual, you said you want a pod, to it running somewhere in a cloud provider like ACI. It doesn't have direct access to the Kubernetes API, so it's really going to leverage Virtual Kubelet to get things like secrets and config maps. And it's going to leverage VK, the framework, to handle all of the state reconciliation and all the things that are necessary. It just follows an interface and makes whatever that interface asked for happen. So here's some current providers that we have. There's quite a few of them. Alibaba uses it pretty extensively. Azure uses it for ACI, which is our container as a service tool. We use it for providing virtual nodes inside of AKS. You can see a whole bunch of other ones like AWS and HashiCorp Nomad. And I'll turn it over to Harry to talk about how they use Virtual Kubelet.
Yeah, thank you. So I will introduce two very interesting use cases of how Alibaba is using Virtual Kubelet. So the first use case, is, as you can show here, is just like what Microsoft or Fargate is doing. And actually, we are using Virtual Kubelet to build one of our most important products, which name is Serverless Kubernetes. So whenever you are using Serverless Kubernetes on Alibaba Cloud, we actually create a control panel for you, but there's no nodes. There's 0 nodes. And whenever you want to have a node, for example, you deploy a pod, then Serverless Kubernetes will be triggered to create a virtual node for you. That virtual node is actually provided by a project which name is Viking. A Viking project is actually a wrapper of Virtual Kubelet. But in order to handle more complicated use cases, for example, the kubeproxy, kubedns, and to support the ingress, we use Viking to handle the rest of the things besides what Virtual Kubelet is doing today. So in order to make it happen, so the serverless Kubernetes basically will give you the infinite resource pool. And this resource pool is actually provided by the Elastic Container Instance service in Alibaba Cloud, which is basically like Fargate or ACI from Microsoft. And the ECI instance is actually a virtual machine, but this virtual machine is not user-faced. And in this virtual machine, first of all, we will have containerd running inside. And then we have a Viking engine to handle the requests from Virtual Kubelet and to send requests to the monitoring service, load balancer, or DNS service in Alibaba Cloud. So you can see here we're using Virtual Kubelet, and we have the Viking engine to handle the rest of the request. And then your pod will be delivered to this ECI instance. And that is how we create a serverless Kubernetes for every user of Alibaba Cloud. And these users do not care about virtual machines or hosts. They do not need to care about their resource boundary because theoretically they have an unlimited resource pool here. So that is how we are doing the serverless Kubernetes stuff. And the second example is how we are using Virtual Kubelet inside Alibaba. So Alibaba is very interesting because, first of all, it's offering a public cloud product, just like I said before. And also, we are supporting the whole Alibaba e-commerce platform inside Alibaba. So in order to do that, we are actually using a very interesting architecture here because we are using a multi-tenant Kubernetes cluster. But in this Kubernetes cluster, which is shared by all the tenants from Alibaba, we actually create a so-called virtual cluster for every tenant. That means every tenant will have a dedicated control plane. They will have their own Kube API server. They will have their own Kube controller manager. But as you can see here, for this virtual cluster, how their nodes come from. Actually, these nodes come from two different approaches. The first approach is from the real cluster underlying cluster. And actually, from tenant view, they only saw virtual nodes. They do not know about where are these virtual nodes come from because virtual node is basically an API object which is created by virtual node agent or the virtual kubelet. So what's the difference? The difference is like this. Whenever the tenant creates a pod, it will actually be delivered to the real Kubernetes cluster here. And this real Kubernetes cluster is running on top of the bare metal machines. So this is a most common case in Alibaba Cloud, inside Alibaba Cloud. But also we have some very interesting user cases. For example, for the Alibaba 1111, we will need to handle like 500,000 transactions per second during the midnight of 1111. That is on November 11th of every year. So then we need to borrow resources from other teams' cluster. We need to borrow resources. And how we connect to the other teams' cluster, then we will use virtual cluster. For example, in that case, we will use virtual cluster to borrow resource from, for example, the ECI service, which is not the resource pool we have, but we can borrow resource from them. And also, we can even use Virtual Kubelet to borrow resource from other teams who also have Kubernetes running inside Alibaba Cloud. So we can borrow resources from different teams by using Virtual Kubelet. So this is a lesson we learned of how we use Virtual Kubelet inside Alibaba. So first of all, Virtual Kubelet is a very interesting project which can help you, which can make you to borrow resource from unlimited resource pool. That is how we handle some burst of the requests during like Double 11 events or other like sales events in Alibaba Cloud. And also, Virtual Kubelet is also a very interesting approach for you to implement a virtual cluster-based multi-tenancy model here. So this is actually what we are using with Virtual Kubelet inside Alibaba Cloud.
Cool. Thank you. That's really interesting. So let's take a look at what it would look like if you want to build a provider. So I'm going to switch over to Visual Studio Code, and we'll walk through some code right now. Actually, let me go to the browser, and we will look at the repo real quick. I have a million tabs open. So you can find Virtual Kubelet at github.com/Virtual Kubelet. Yeah, I'm going to share it in 1 second. Display settings, here we go. Mirror. Okay, so let's go back to this window now. Okay, so there's Virtual Kubelet. You can find it at Virtual Kubelet/Virtual Kubelet. And inside of here, you'll find a bunch of code right now that does a few things. You can find in the CMD Virtual Kubelet folder, this is where the daemon's defined. So you can go in there, and that's really the entry point. So when you're going to run VK, you're going to run that process. And you can use that as a way to kind of dig around to where the rest of the code is located. Inside of the providers folder, you can find implementations of all the current providers. So we can see there's Alibaba Cloud, AWS, a couple of different Azure ones, Huawei, Nomad, OpenStack, and we have a REST API for scheduling things. These are going to actually move out of the tree soon. We're trying to work right now towards doing a 1.0 release this week. And as part of that 1.0 release, we want to make things a little bit more maintainable. So we've been trying to harmonize and figure out what the exact API for the provider should look like. And we've gone through, and you can see like there was a commit that touched almost everything in here, where we actually updated this to what we think the 1.0 API is going to look like. And then in the vkubelet directory, this is where the magic actually lives. So there's some things in here like pod controller, node.go. And these files are going to define all the logic that's necessary for like faking out a node and reconciling the state inside of the pod controller, defining interfaces, things like that. OK, so let me jump back to Visual Studio Code now, and we'll actually look through that stuff in an IDE. It's a little bit better. So the most important thing in here, is vkubelet. So right now, the server piece acts as the main lifecycle for VK. Inside of that, you can see a couple things. There's a K8s client, and that's how it's going to actually talk to the Kubernetes API using client Go. You can see things like provider, resource manager, and those are things that are going to be what's actually talking to the provider and figuring out how to schedule those things. Then if you scroll down a little bit more, just information on how to construct that thing. In pod controller, the really important piece of how you would implement your own provider for VK starts with the pod lifecycle handler. Inside of that, these are the methods that are actually necessary for implementing a provider. So create pod, update pod, delete pod, get pod, and so on. And they're actually operating at the pod level, so not individual containers. It's going to take the pod spec and pass that to the provider. And the provider is really responsible for figuring out how to take that pod spec and turn it into the necessary calls that go along with that. And then inside of API, you can find server.go. And server.go is where the HTTP handlers are defined right now. So for example, /exec namespace pod container. That'll end up calling back to a handler function. Those things are defined right here. And that's what you're going to implement inside of your provider. So as an example, we'll look at the ACI provider to show you what this might look like. Oh, right here. So inside of here, you can see there's a whole bunch of methods that have collapsed because they're not super interesting for this case. But let's look at the create pod method, which is right here. So on that method, let's hide this window. So what you can see in here is that we get the pod spec itself, and this is just a Kubernetes pod definition, just the normal object you get from the API server, like that. And we start to iterate through it. So we get a list of all the containers that are in that pod. We figure out what image pull secrets are necessary for those containers. We get volumes that are attached with those from the provider itself. And then we start to build things up. The way you schedule something in ACI is really analogous to a pod. So we have something called a container group, and in that container group you define 1 to n containers. So really what we're going to do here is turn that call, or that pod spec, into a call to create a container group in ACI. And we're going to populate all the things that are necessary to make that happen. And then we keep going down here, and eventually we are going to call the ACI client. So we've gone through and we've translated all of that pod spec into the necessary implementation of Azure, and then we call the client, and the client actually makes that happen for us. Then we update status, and we move on. So later on, if we want to update something, let's update pod, create or update. So back in the pod controller, this is where the reconciliation is happening. This is going to get invoked, and once it determines that something needs to be deleted or created or updated, it's going to invoke those necessary methods back in the provider. So in this case, we're making a pod. We're going to invoke that create pod method. It's going to come through this logic, and right here it'll say server create or update pod, and that's what's going to turn into the call back to the provider and invoke this method eventually. And you can see in here, there's examples of how to do the same thing for deleting and getting pods, all of the lifecycle operations you'd have to do to implement that provider yourself. All right. Back to the slideshow. So super exciting, Virtual Kubelet is going to hit 1.0 this week. And what that means is that the API is pretty much stable. Some things we're going to do going forward are, again, break out those providers so they're not living in the tree. And it's a little bit easier to maintain the Virtual Kubelet daemon for a specific cloud provider. A lot of the configuration and stuff right now is kind of split amongst all of those things. So it makes the Helm chart slightly hard to maintain, a little complicated. So we're moving towards stability and having a little bit better maintainability of everything. I showed you the GitHub repo earlier, so here's a link to it again. If you're interested, if you have questions you want to ask about VK, you can find us on the Kubernetes Slack in the Virtual Kubelet channel. We also have community meetings every other week on Tuesdays at 11. That happens on Slack, or on Zoom. If we go to the website, you can find that page. You can find recordings of previous ones as well. Let's find the community. Somewhere in here.
Share screen.
Oh, am I sharing? Yeah. Oh, sorry. Switch back. Slideshow. So you can find information like how to contribute and who the maintainers are currently for each of the providers if you have issues, what our lifecycle looks like for accepting patches. All that good information you'll be able to find inside of here. We obviously follow the CNCF code of conduct. And we'll come back in here. Cool. No. From current slide. There we go. Again, so we have community meetings every other week on Tuesdays at 11 Pacific time. And CNCF has accepted Virtual Kubelet as a sandbox project. That happened right before KubeCon last year. So that's why we're here today to talk to you about it. And we built a bunch of time in to answer questions. So I'll move on to that now. And if we don't have questions, I'll show you some more code. So we'll open up to questions now. Anybody have questions? Go for it. We'll repeat the questions for you too, or you can use the mic.
So I get that it kind of looks, feels, and smells a bit like a node. Mm-hmm. But when I deploy nodes at the moment, I have to think about things like availability and spreading them across fault domains. have to think about things like performance.
Yep.
Can Virtual Kubelet deal with things like that, or is that something that will come? Or?
So Virtual Kubelet itself won't deal with that. Virtual Kubelet's providing the interface for you to connect to some other thing that will handle that for you. So in the case of like ACI, you're going to know when you configure Virtual Kubelet to use ACI, what regional, like what availability zone it'll be in. Same thing for Fargate. So if you want to handle like across fault zones, you can create multiple VK instances that would be in multiple availability zones. You can handle that by just assuming that it's a cloud provider service, and there will be some level of guarantee about like the SLA for the things that are scheduled inside of it.
Assuming that I just say let's balance across 2 fault domains, so that would just literally be 2 virtual kubelets, one pointing to each. I don't have to think, I need 5 virtual kubelets in this fault domain for a really simple use case. No?
Yeah, I mean, it's going to depend. It will depend on the backing provider, right? So if you are having a provider that's maybe spinning up virtual machines and then scheduling containers on the virtual machines, you'll have to worry about where those virtual machines end up. But if it's something like VMware's, Azure ACI, it's going to have kind of like an endless, whatever your subscription accounts for, supply of stuff, right? So that one you don't necessarily need to think about how much capacity I have, because it's not going to be tied to the number of virtual kubelets. It's going to be tied to whatever the backing provider service is. You can ask the question, and I'll just repeat it so we get it on the mic so we don't have to run back and forth.
So in a hybrid cloud environment, may run into a situation where on bare metal I've had some number of pods and I'd like to burst into the cloud. How would you, is there a way to configure a horizontal pod on this node to use it exclusively virtual kubelet or something like that?
Yeah, you can. So we have a couple of demos where we have used things like admission controllers and an HPA to do that kind of bursting scenario where so one of the things that I didn't mention is that Virtual Kubelet taints itself as a node. So to actually schedule things by default, you have to apply that toleration so that they'll get scheduled there. So you can use, through that you can make it kind of go that way. The HPA will scale, because it's just going to create new pods, right? Like when the HPA decides that it needs to make another replica, it's going to just create a new pod, and VK will just pick that up, assuming that it has the toleration applied to it. Does that answer your question?
Kind of, but I still want the pods, the original pods, to be scheduled on-prem. So I would need the toleration would also prevent those pods from being scheduled, or else new pods have to be scheduled on-prem as well.
Yeah, so it would allow them, there's not a way to really, you can't really force the scheduler to say, like, only go here. You can say, tolerate that node so it can get scheduled there. I guess it really depends on what the scheduler defines or decides is available. So I guess the answer to the question is no, you can't just say, only go to VK. You can't do like static pods or anything where it's just gonna end up on a single node. But that is a use case we see people like using it for like a hybrid cloud situation where it's on-prem, and when they run out of capacity, burst into the provider.
It's close.
Yeah.
It's close. You mentioned that you can configure the virtual kubelet to report infinite resources. How do you do that in practice? Do you report a very large number?
Yeah, it reports a very large number, so like 4 terabytes of.
So in Alibaba Cloud, we definitely have a virtual kubelet which report the whole resource capacity of this cluster. It's very huge. Yeah.
Yeah, so it could be, the provider is really going to report that back. So in your provider, you could basically report an infinite number. You could report like back a realistic number too, whatever the real capacity is, to take advantage of the scheduler. When you are using something like ACI or what Alibaba's doing, when it appears as an infinite node, things will just keep going to that node over and over again.
So if I understand well, Kubelet is like an interface and provider are implemented. Is there some limitation on this interface? I mean, for example, the source limit request, is it implemented or
So the question was, are there any limitations when using Virtual Kubelet versus a regular node? Is that a summary? Yeah, so there are. Virtual Kubelet doesn't conform to a regular node. There are things that will never really be true about something that's not a physical node, like having attached storage necessarily won't map to every use case. VK itself doesn't try to impose any of those things. They're going to end up being limitations of the provider. So things like resource constraints, it's not going to really decide. Some of that is the scheduler designing, like, well, this can only get so much. But those things will be passed down to the whatever the provider does. So in like the case of ACI, we do honor constraints. So like if you only want to run like a 1 gigabyte of RAM in a container.
Is there kind of pass-through about the pod data?
Yeah. So if I go back to the code real quick, let's jump out of here. So in here, create pod. So this is getting the entire pod object. So like when VK says, I need to go create that pod, it's going to pass the whole thing down. And inside of here, we're looking at things like, what is the operating system type? What's the restart policy? Get containers. Let's go to that. Yeah, so inside of here, what ports are defined? It's going to get the entire spec and figure out what it can do with that spec as it's operating. Cool, let's go back in the blue shirt first. We haven't really built, so the question was, is there a provider right now that'll do like Kubernetes and Kubernetes? So we don't have that right now. You could build something like that. We've been mostly focused on providing different kind of use cases than that, connecting to external resources, doing that kind of bridge where there's not that traditional, like there's no kubelet available, or you're trying to bridge to another scheduler type. But it would totally be possible to do that. You could build a provider to do almost anything, as long as it's conforming to that interface. Okay, green shirt.
So how are the things that require some kind of node to work? So they would have the demo set, they may have network or log segmentations.
Do we support daemon sets right now? Yeah, so there are some limitations right now with VK, and daemon sets is one of those things where it doesn't automatically pick up and schedule, because there's not really the concept of, the providers don't have, they're faking a node, but they're not really a node. So some things like daemon sets don't get implemented yet, may or may not get implemented in the future. But in general, it's going to handle things as a node would. Does that answer your question?
Yeah, also the log segmentation or log collection.
Yeah, the log collection. So when you are going to, so there's two forms of logging. There's the logging for VK itself. That's available. And then inside of the interface here, if we go back down to server, one of the things you do to get logs, that comes in through the HTTP endpoint that the Kubelet has. So that's handled here as well. And then the providers are really responsible for fetching that and streaming it back to VK for VK to report back to you. Okay, back there in the back. Can I imagine a virtual kubelet for Windows? I can. So the question was, can I imagine a virtual kubelet for Windows? And I don't really have to imagine that because we can do that with ACI and with Service Fabric. So you could write a provider to schedule anywhere, right? So if you have a service that can run Windows containers like Service Fabric, you can make a provider for that. And we have some use cases where or some demos and stuff where we've seen Windows containers running alongside Linux containers. Say that again? Yeah, someone has tried that. Yeah. So the question was, has somebody actually tried that? And the answer is yes. We actually see, at Microsoft, we see a lot of actual Windows container usage for Kubernetes via Virtual Kubelet and some of our backing services. It is. Obviously, there's some limitations. So like with virtual nodes for AKS, can't do Windows nodes right now because it doesn't support VNets correctly. And for virtual nodes in AKS, you have to have VNets to have the ability to talk back and forth between pods. Go again. Are there any complications? So the question was, are there any complications with GPU support? And that's going to come down to the provider. So you can use, like if ACI, for example, has GPU support, you could schedule things to, assuming the node reported back that it supported that capability. Can you replace all of the AKS nodes with virtual nodes? Not yet. I saw somebody on Twitter tweeted that they used, so they were trying to run Virtual Kubelet as a container in ACI on a cluster that had a VNet, and then they scaled down the node, like it was a one node cluster, and they scaled it down, and it was kind of working, but it's not a supported thing yet. Yeah, it's a hacky thing. But like you could envision like a nodeless cluster, as long as you can live with the limit, like, the fact that it's not going to have 100% compatibility with a regular kubelet, but like it unlocks a lot of cool stuff because it's going to give you the ability to do non-traditional things.
So the demos I've seen so far are all about virtual kubelet running within Kubernetes and calling them.
Mm-hmm.
What about running virtual kubelet on an external hardware and calling into Kubernetes?
The question was, what about running Virtual Kubelet outside of the cluster? As long as so VK has to have connectivity to the API server. And as long as it has connectivity to the API server, you could do that.
And how would you have things like TLS bootstrapping?
You would have to solve that externally to VK. But like, as long as you could make all of those complicated things happen, it would be possible. Any more questions? Go for it. Say it one more time.
When I buy an ACI instance, does Virtual Kubelet automatically deploy on it?
When you use ACI, does Virtual Kubelet automatically deploy onto it? So you have to deploy Virtual Kubelet into your cluster first and configure it to point to that ACI instance. It's not an automatic switch that just comes for free with ACI all the time. It's going to be a situation where you're going to configure your cluster to have VK as any number of VK nodes, but it's something that you have to configure to wire up. Where does the Virtual Kubelet run? By default, it's going to run on the cluster. So like if we go back here for a second, one way to install it just generically is to use the Helm chart. And the Helm chart is going to create a deployment for Virtual Kubelet. So just a regular Kubernetes deployment that will start up that daemon that registers itself as a node. You could run it externally from the cluster as well, assuming you can handle all of the TLS and the authentication and connectivity between VK and the API server.
Are there any limitations
Any limitations over?
with service mesh?
With service mesh solutions? I don't know. We haven't really tried it with a lot of service mesh solutions
Actually,
yet.
we tried this.
Have you?
Yeah, on Alibaba Cloud, you can actually use Istio
Nice.
on top of Virtual Kubelet-based Kubernetes. It works very well. Yeah. The only issue we need to fix is about the DNS part. That's why we said we have the Viking project to handle the ingress DNS stuff. That's the only blocker.
That's pretty cool. I'm gonna try that. Any more questions? No? All right. Oh, go for it. We don't do static pods. I had that question when we were in Seattle. There's nothing that really would prevent us from supporting static pods. You could probably call VK directly and try to create something that was analogous to a static pod. But since it's really driven from the API server and static pods don't end up in the API server, they'll try to create like mirror pods and stuff, but you don't create them via the API server to go to the kubelet the same way. So it's really driven by the API server right now, like a controller would be from some other resource. Cool. Well, thank you so much for coming today.